All right, this is the very first slideshow going over the review for our American Chemical Society final review. We will call this part 1, and you should really take some good notes here. It's going to be questions 1 through 16. Okay, so I will go through question by question so that you can have some notes and even additional reference on each of these questions. So this is a review of the entire year of chemistry, and one of the first questions is going to be dealing with significant figures, and one of the things that gets tricky with significant figures is, of course, the zeros. Good morning, Shelby. So in this case, this zero, this very first zero, is not significant. It's important to put there, but it doesn't have any numerical significance in terms of measurement. Just kind of, these are place fillers. So when you have numbers less than 0, I always say it's just no, no, until you hit a non-zero number, and then they'll always be significant. Even if there was a 0 on the end here, that would be 5 significant figures. So it's just the leading zeros till you get there that would not be significant. Now, that's the opposite for big numbers. This is 450,000. So it's no, 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 no until you hit a non-zero number. So this would just have 2 significant figures. So in other words, this is a way of saying about 450,000, plus or minus 10,000 kind of thing. All right. And the book reference for this is section 2.5. So I strongly recommend using those book references and maybe adding a few more examples, especially if you consider this one of your weak areas. Because, and I know that some of you are still struggling with significant figures. So just reread that section and look over some more examples. Okay, so that's question number 1. Excuse me. Question number 2 deals with density. Density is defined as mass divided by volume. So you'll need to apply that. The units that they're going to use on the American Chemical Society test, they'll write gram times cm to the minus 3. So this is important to note that instead of putting cm in the denominator, you can write it in the numerator as cm minus 3, something that we do in AP chemistry all the time. So if that is risen to the negative 3 power, it means it's on the bottom of the unit. So you don't have to get bent out of shape about that. And again, a book review, section 2.8. All right, now, question number 3 is a thinker about a lab scenario. And there's a couple things you should know about ammonia. Ammonia is one of the most discussed molecules that we've used all year. First of all, ammonia is very soluble in water and is less dense than air. Now, I've attached a video. That covers the concepts, and it's pretty cool. I like to think that this scientist is what I'm going to look like in about 10 more years. But I really like him and I like his videos, so definitely watch that, and that will definitely help you get some bearings on answering question number 3 intelligently. Okay, and then moving on to question number 4. Again, you might want to pause these and get this all written, and then you can listen to the descriptions. So when they have lots of stuff like this, go ahead and hit the pause. That's what we're going to do in class. We'll just stop and have everybody write everything, and then we'll discuss it. Okay, welcome back. And this is making a statement that for any gas, no matter what gas you're talking about, if you're at standard temperature and pressure, 1 mole will equal 22.4 liters. And that is 6.02 times 10 to the 23rd molecules, like CO2 is a molecule. This is ethane, the molecule, nitrogen monoxide, and a diatomic molecule, like in the Magnificent Seven, or if it's just a single atom, it doesn't matter. And it doesn't matter the size of these either. They will occupy the same volume no matter what they are. That concept will really help you. And if you read through and maybe even take additional notes if you want on section 1310, that'll get you ready for question 4. Number 5, what is the total number of atoms in this molecule? Should be pretty darn good at that from like our atomic weight calculations, our molar masses and formula weights and so on. You just need to carry these through here so that there are 4 nitrogens, and then 4 times 4, 16 hydrogens, 4 phosphorus atoms, and 7. So then you total those up. And you wouldn't need a book reference on this. Number 5 is if you're careful and you write it out, there'll be the right side of the test is going to be blank. There'll be plenty of room for you to write it out and count it up and tally it so that you avoid making a silly mistake. Because one thing about this test, they have good fake answers. They know the common mistakes, and just because when you tally it up you're like, oh, there's the answer, I must have gotten it right, I would be careful about that. Number 6 is again, pause and write this down, but this is talking about when you have a non-metal and a non-metal. Then you're going to use the prefixes on the bottom of your yellow sheet, and you're not going to name it as if they were ions. You wouldn't put a Roman numeral in there and call this just regular oxide, but you have to use the prefixes to say how many of each, like carbon dioxide is a perfect example. So in this case it would be diphosphorus. Notice the first word comes from the periodic table, just the name of the element, and the second one, it doesn't say pentaoxygen, it says pentoxide. Notice you drop the A on that. So pentoxide means 5 oxygens, and you can get the name of the second one from your yellow sheet. The top half of that yellow sheet has those singular atoms with their prefixes. The negative ions. Well, that would be a negative ion, but in this case, it is covalently bonded. Okay, so section 5.3 goes over all that. You can get good at naming binary molecular compounds where they're both non-metals. All right. Number 7 is balancing a chemical equation by just adding the correct coefficients. Some of you, I think, still need a little bit of review on this. Take your time on this one. Write the equation out. It's got that blank half. I am going to kind of look over, you're going to take a picture of the pages of the test and send them to me, and I'm going to be looking for that work. Okay, so make sure that you show work on these problems. As you're going to have plenty of time to take the test during the hour. 16 multiple choice questions are pretty reasonable, but they are tough problems, and they do take some thinking. Something like this one, write it out and don't make silly mistakes. So the book reference for balancing chemical equations is 6.3 if you think you need to refresh that concept. Number 8 is the complete combustion of propane. The questions aren't. I'm just giving you some examples that would be helpful for you in these problems. So what you have is there's the formula for propane, because you know how to count to 4 in organic. This is 3. Double that, add 2. And it's reacting when you're combusting something, you're actually reacting with oxygen. And, of course, in complete combustion, the products will always be CO2 and H2O. So the only thing that would be different would be possibly the hydrocarbon that you have. The book reference for combustion is section 7.7. They talk about combustion reactions. Okay, now for number 9, it talks about glass and the chemical formula of glass. So this one you're going to have to look up. There's quite a bit of homework if you're shooting for the A and you're shooting for really doing some things to raise your grade, because these are going to be worth a lot of points. And all these sections, and if you want to get this one right, you're going to have to look this up. There's an example problem in section 6.3 that shows a reaction of glass with hydrofluoric acid. Hydrofluoric acid is a acid that reacts so much that it would actually eat through glass. So find that. Get that book out, section 6.3, and see what that chemical reaction is. Write that down in your notes, and then you've got it right there. Oh, that's the formula that I'll need to answer that problem. Okay? All right, and we're going to do 10 through 16 on the second video.